This question, A, you could do the long way. At u substitution, you could say u is equal to x to the fourth, and du is equal to 4x cubed dx. And then you could divide by 4 on both sides. There you go. And you could just do this whole thing out, and it works perfectly fine. But you could just be lazy. You could be lazy and say, well, x to the fourth, what does that look like? It looks kind of like that. So it's an even function. But wait a second. This is sine of x to the fourth. So sine, okay, well we're going to, but sine, we're applying the same thing to the right and the left. So the same thing is going on. The whole piece is even though sine itself is odd, but sine of an even function is an even function. So, and then we're going to multiply that by an odd function, but what that's going to end up giving us, since this piece is odd, this is going to be an odd function. Okay, so the whole thing has to be 0. Okay, so then that, if you just give me, this kind of discussion, that's good enough. I see you're doing an even-odd analysis and you're looking at what's going to happen. That's perfectly fine. You don't need to show any work for that. I sometimes throw in these, often throw in these little cookies for people who are paying attention, so that you don't have to work very hard and you can get the answer. It saves you some time, and your reward is, you get done with the exam sooner. Okay, then we have the next question, and that's a u substitution, which you actually have to do out. Sorry, I put the u on the other side. It doesn't much matter. Again, by the magic of this eraser, I can just put the 2 over there. Then I just rework this problem. X dx is du over 2. And then I say, well, I would really rather have u to the minus 1/2 du, and so on and so forth. And then what you end up with is, let me just jot these pieces down here. You end up with u to the 1/2 plus c, which becomes square root that we had already. Alright, and if, I'm sorry I didn't give you much room here, you meaning the people before you. And if it's hard to see where your answer winds up, just put an X in our box around it, rather. Because see, we started over here, and then we worked over here, and then we went over here, and that's really hard for me to follow this kind of thing, and you really have no choice, right? Sometimes it just happens. So if your work is circuitous like that, then just put a box around your answer, please. But if your work flows in an obvious fashion, that's, not necessary. Okay, the next question is really nasty. It's nasty, but you're seeing it now. If it's part of the review, then it's fair game. And this happened when I gave this question. It was not the first time the students had seen it. So I don't want you to think that I would just pull this kind of question out of the air without having prepared you, because it would have to be rather inspired of you to have thought of splitting this up. I mean, putting the 1/2 on one side and the 2 on the other side, that's just prettiness. It doesn't matter. But really the idea here is we're splitting off the x squared from the other x. So we're splitting this, 2 x's go one way and 1 x goes the other way. And that's the piece that's a little bit inspired. You wouldn't necessarily think of that. Okay, so du is going to be x dx, and v is equal to e to the x squared. I mean, you can use u substitution on that piece to figure out y if it's not obvious. But you can just take the derivative of v and see that you get back to where we came from. Then we go uv minus integral v du, u v minus integral v, oops, du, sorry. And then we do have to use u substitution on that piece again, and it's going to be pretty straightforward. But you see, this little piece is going to be u, and this piece is dv, and then du is equal to dx, and v is e to the x squared, right? Oh, I'm sorry. I'm lying to you. Sorry. You shouldn't believe everything I say. All right, this piece is u is equal to x squared, and then du is equal to 2x dx, and then du over 2 is x dx. So then you get e to the u du, and you get a half. Okay, so then you're going to get e to the u over 2, e to the x squared over 2. Okay, great. So now we just pop this piece in. So there's a minus because there was a minus over here. And then you're going to get e to the x squared over 2. Now, all this mess, 1 to 0. Okay, and then that's when a lot of people are going to actually start making their mistakes. They've been really careful up to this point, and then they're going to mess something up, and I'll show you what not to do. So, the 1 goes in here, and you get 1/2 e to the 1, so it's going to be e over 2. Big deal. Then you're going to put the 1 in here, and it's e to the 1. Okay, so you think, no, this can't be happening. But that actually happened. Now, we're going to put a 0 in here, and this is when people are going to be lazy. They're going to be like, okay, 0 minus 0, and the whole thing wipes out. But that's false because e to the 0 is 1. This negative distributes, and this actually ends up being plus 1/2. So, and I'm saying this because I have seen this kind of thing happen a lot, where people do the hard part and then they mess up at the end because they run out of steam. This little mess that I was making down here, I'm not going to re-record. I'm going to let you hear that mess because students often learn use substitution, and they learn parts at about the same time, and they're not the same. But on first glance, the problems that they solve appear similar. And so you have to watch out. So if you start working a problem and you're just going nowhere and it's just completely nuts, just ask yourself if you're using use subs when you're supposed to be using parts, or trying to use parts when you're supposed to be using use substitution. And that's just a quick sanity check to make sure you're on the right track. Okay, hope that helps.